Previously, we worked on a problem that dealt with converting between a certain number of moles of carbon atoms and then determining how many carbon atoms are present. Here we're going to do something very similar, except instead of having just an amount of an element, we are going to have an amount of a compound, and we'll have to determine how many atoms are present of a particular type in that compound. So for instance, what I mean here is we have benzene, and we're dealing with benzene in this problem, C6H6. And we have 1.2462 grams of benzene, C6H6. What we want to do is we want to determine how many carbon atoms are present in that 1.2462 grams of carbon, or grams of benzene. How many carbon atoms are present in that many grams of benzene? Now, we have seen a number of times this idea of the molar mass. We've talked about it before, this idea of the mole concept. And what the mole concept is that a mole is a unit, just like a dozen, where it tells us how many things are in that particular mole. So a dozen, there are 12 things in a dozen. In a mole, there are 6.022 times 10 to the 23rd things. Now, we normally use this for small things like atoms or molecules, but it can be anything, anything at all, just like we can have a dozen of almost anything. What makes it useful for small things is that it's a collection of a very large number of things. So we can take care of or account for a large number of things by using a relatively small number of moles. And so what we want to do is we want to end up with atoms of carbon that are in this number of grams of benzene. So we want to go from grams, and we want to end up at the end with carbon atoms. Now, we know the definition of a mole is number of 6.022 times 10 to the 23rd things in a mole. So we could go from atoms to moles or moles to atoms to get that final answer. But remember that it's not so simple. We don't know how much carbon is in this particular compound. At least we don't right looking at the problem. So we're going to need to also go to moles of benzene and then go to moles of carbon, and that will allow us to calculate the number of atoms of carbon. So let's go ahead and start working through that. The first step is we need to get from grams of benzene to moles of benzene. And to do that, we need to know what the molar mass of that compound would be. Remember C6H6, the way that we would determine what the molar mass would be is we would say there are 6 carbon atoms, so 6 times 12.01, and there are 6 hydrogen atoms, 6 times 1.01. Those are just the atomic masses of carbon and hydrogen. We would add that all up together. And before I do that, I just want to make it clear one more time. Notice I always take at least a minimum of 2 decimal places for every atomic mass from the periodic table. You can take more than that if you want to, but I'd say a bare minimum would be those 2 decimal places. It will throw your answers off if you don't take enough decimal places. And a lot of students have trouble where that they will round those molar masses a little bit more, those atomic masses, than they need to. And you should work this out to be 78.12. What is this number? Well, it's the molar mass of benzene, but it tells us how many grams are in 1 mole of that substance. So if I have 78.12 grams of benzene, I will have 1 mole of benzene molecules. So notice, this allows me to go between grams, 78.12 grams of carbon, of benzene, in 1 mole of benzene. So notice I've gone from my grams to my moles of benzene. Now I need to get from moles of benzene to moles of carbon. So my grams have crossed out. If I stopped now, I would have figured out how many moles of benzene are in this 1.2462 grams of benzene. So now I need a conversion factor between moles of benzene in moles of carbon. So that is very straightforward, although this is again one of those things that students tend to have a hard time getting their heads wrapped around, is that in 1 mole of benzene, C6H6, there are 6 moles of carbon atoms and 6 moles of hydrogen atoms. I'm using the stoichiometric ratio, or the stoichiometric coefficients that are contained directly in that formula. So 1 mole of benzene contains 6 moles of carbon atoms. Now, I've gotten rid of, or I've canceled the moles of benzene. If I stopped, I would know how many moles of carbon that I had in the 1.2462 grams of benzene. Not what I want. I want to know how many atoms. So I still need that last step that's going to go between, or convert between moles of carbon and atoms of carbon. So I need to have that conversion. So this is all going to come down to the definition of the mole. 1 mole of carbon is 6.022 times 10 to the 23rd. Avogadro's number, the number of atoms of carbon that are in 1 mole. So now moles of carbon are gone. I'm left with my atoms of carbon, which is what I wanted to end up with, and I should get 5.764 times 10 to the 22nd carbon atoms. You might say to yourself, does this answer make any sense whatsoever?